Hi, welcome. Now I'm going to show you how to solve distribution problem in Excel. Okay, the example what I have here I will explain to you first, then I will go to the solution part. Okay, so any distribution problem has three parts. One is understanding of the problem, and second and formulating. The next one is the formulating on the of the problem into the Excel worksheet. Okay, that is also a very main and critical part. Then solution of the problem. Okay, how we are going to solve it. If you are not formulating the problem properly in the Excel worksheet, then you cannot solve the problem, or it will be very confusing while you are solving the problem. Okay, so the problem what I have it in for example here is that the plants and the distribution centers. Okay, the plant having the source, okay, they are the one manufacturing our product. For in this example it is car. Okay, and the products, each product is manufactured in all these three plants. Okay, it's the same product. Okay, then what is happening in the distribution center? Each distribution center receives the product from the plants and sell it to the customer. Okay, so they are the selling units. Okay, in this example. Okay, in the plant also have the capacity. Okay, so each plant, big or small, according to that it can, according to the manpower and machinery, it can produce only 1400 cars. Okay, 1400 cars for this particular month or quarter. You can keep it whichever you want. Okay, so the plant A have the capacity of 1400 products, plant B can produce 1900 products, and plant C is 1600 products. Okay, similarly each distribution center, the selling units, also having the demand. Okay, the plants having the capacity limitation, and the distribution centers having the demands limitation. For example, distribution center 1 can sell, okay, or distribute only 2300 cars for this quarter. Similarly, for a DC2 can sell or distribute only 1400, and DC3 is 1200. So they have the demand, okay, restriction, and also the plants having the capacity restrictions. Okay, so I put a capacity here directly for each plant. Okay, so finally we also have something called the price involved. Okay, the expense involved or the cost involved in this the plant A to send a particular product to distribution center 1, the cost is $80. Okay, so I put it as $80. It could be 80 hundreds of dollars or 80 thousands of dollars or whatever. Okay, so we call it as $80 for simplicity. Similarly, plant B to send a product to DC2, the distribution center 2, is $100. Similarly, plant A can send a product to the distribution center 3 is $215. Okay, and you see the same thing. This is the cost involved, and the cost table is here. So in this matrix you can find for each plant what is the cost incurred to send a product to a particular distribution center. For example, I have plant C and DC3. The cost involved is $102. That is, plant C to send 1 unit of product to distribution center 3 is $102. Okay, this is our problem. Now what we are going to do is we are going to we are going to satisfy the demands by the 3 plants okay, the demands of 3 distribution centers by 3 plants according to the capacity they have. Okay, so we cannot just our objective is to the cost must be the minimum. Okay, for example, if plant A is sending DC1, then the cost of each is $80 and 10 products I'm sending, then it is $800. Similarly, for each cell, the cost involved according to the number of products, the cost, overall costs, we are trying to minimize it. It must be minimum. And the other point we need to see is that because it is minimum, we cannot simply allow plant A to, this is for plant A is minimum for DC1 having the minimum from plant C, so we cannot simply put plant C for DC1, again plant C for DC2, and for DC3 plant B. We cannot simply put, because our restrictions are here that the distribution 1 needs a demand of 2300 units of product, but plant C can produce only 1600 product. Okay, so this is the restriction we have. Okay, so it is not very simply just working on with just putting the value for the minimum cost. Okay, it is also distributing or dividing the products, because of each plants having the different capacity limits. Okay, so this is the problem what we have. What we are going to do is we are going to formulate the problem into the similar fashion to understand what is objective function first, secondly what are the variables involved, okay, or the optimizing variables, what are the variables we need to find out. Okay, in this case it is the number of products. Okay, so number of products for each plant A to distribution center 1, plant A to distribution center 2, and so on. Okay, and third one is the what are all our constraints. Okay, three things we need to find out: objective function, the variables, and the constraints. Okay, so I put it here to formulating the problem, same thing here into the fashion of objective function, variables, and constraints, so that it will be easier for us to solve, to proceed to next step. Okay, what I am having here is the variables first. Okay, for any problem you need to go for variables first. Okay, it is going to be for this distribution problem, it is going to be the same kind of format what we have it here. Okay, for the problem the same thing is going to be here. Okay, so what I am going to do, the same matrix, plant A, plant B, and plant C, C1, C2, and C3. Okay, instead of cost, here I have per unit cost. Here I have it, I am going to have the variables of number of quantity I need to order from plant A to DC1. Okay, so what is the number of quantity? Okay, that is our objective. Overall objective is to find the number of quantities for each plant and distribution center and minimize that cost. Okay, so that we can minimize the cost. Okay, so these are all our variables. So the variable cells I put it is same like cost table. Okay, what is this point? Plant A, what is the number of products plant A has to send to DC1? Okay, and the number of products plant A to send it to DC2, number of products plant A to send it to DC3. Okay, so each cell will give you the number of product. Okay, this is what we are going to find out. These are all called in Excel terms, it is changing variables. Okay, why it is changing variables or changing cells actually? Okay, why they are changing cells? Because we are going to, the problem is going to put different values to these cells to find out whether the overall cost is minimum. Okay, the iteration values are going to be here, and also you can put your initial solution. If you know some initial solution, or you are doing the problem, it is taking too long. If you run the problem for 2 hours, then you get the answer, but still it is not optimal solution. You just keep that one as a starting point for the next day when you want to run it. Okay, for the other iterations, again you run it for another 1 hour, then it will get a solution. For this kind of small problems, within 5 minutes we can solve it. Okay, what we have here is the changing variables. These are all the variables we need to find out. Okay, number of products. Okay, that is our objective. Okay, these are all the, so each cell is number of product of plant A to DC1 and into plant A. The unit cost of plant A to DC1 will give total cost for the plant A to DC1. Okay, so if you multiply each this number of products with the cost coefficients matrix, or in other words it is the cost incurred. Okay, each cell, corresponding cell, if you multiply, you will get the cost in each plant to distribution center. Okay, if you add all the costs, then you will come to objective function. Okay, so what, these are all the variable costs. Okay, so these are all the variables we are going to find out. They are called the changing variables or changing cells. Okay, now each variable itself is a cell. Instead of we say it is x11, x12 and so on, we just leave it as Excel's name J5. This is cell K5 and this is L5. Okay, because we are not going to refer anything, we just click and just drag kind of thing. So we no need to rename the cells into anything else. Okay, so now we have the capacity constraints. Capacity constraints are each plant, the plant A can have only 1400 products, can manufacture only, plant A can manufacture only 1400 products. So the capacities, we are going to have the constraints from left hand side and right hand side. Okay, what is the left hand side of the constraint and what is the right hand side of the constraint? So the right hand side is obviously equal to the capacity of each plant is going to be the capacity is what we have it in the problem. Okay, so for the plant A can give only 1400. Okay, plant B can give only 1900 and so on. So the capacity is right hand side is 1400, 1900, 1600. Okay, what is the what is the left hand side of the constraints? Okay, this is right hand side of the constraint, this is left hand side of capacity constraints. Okay, or you can say the plant constraints, whichever is understanding. Okay, for what we are going to do is okay, now what I'm going to do is left hand side and right hand side of the constraints. What is this one is equal to, okay, the product what plant A is going to send to DC1, DC2 and DC3, the number of products for each distribution center the sum cannot exceed 1400 because the capacity is 400. So my sum of plant A's product to DC1, plant A's product to DC2 and plant A's product to DC3, the overall sum, if I add all the products, send it to all the products from plant A to all these 3 distribution centers, must be equal to 1400. So all these cells value must be equal to the sum of products to each distribution center from the plant A is equal to 1400. Similarly, it has to be, I just drag and shift these cells, all these cells values J6 to L6, if you add it for plant B to all 3 distribution center, this is 1900. Okay, similarly for plant C. Okay, so it is very simple that we are splitting the constraints to LHS and RHS. Okay, this is the capacity constraints. Okay, so similarly we also have demand constraints, capacity constraints for plants, demand constraints for distribution centers. Okay, so what is the demand constraints? Similarly, I have demands of distribution center 1 is we can send only 1300 products to DC1. Okay, because DC1 having the demand of 2300 products. Okay, so similarly we have other 2, DC2 and DC3 also have the demands. Okay, DC2 having 1400 products, DC3 is 1200 products. This is the right hand side of the demand constraints, the value. Okay, left hand side of the demand constraints, or you can call it as distribution center constraints. Okay, a distribution center, okay, can receive the products from plant A, plant B and plant C. The total products, if you add it and see, it must be equal to 2300, its demand. Okay, so it can have it any number of products from any plant A, B, C and ABC, but the total must be equal to 2300. It cannot move more than 2300 because the demand itself is only 2300, and it cannot be less also because it has to satisfy the customers. Okay, now this is also similar, sum of all 3 number of products from all 3 plants to distribution center 1 is left hand side supposed to be the sum of all these number of products from each plant. Okay, right hand side is supposed to be equal to 2300. Now currently it is 0 because our cell values are 0 here. Okay, we are not distributing any product to any distribution center. Okay, so that's why it's 0. Once we started changing the values, it will change, but we must make sure LHS is equal to RHS. Okay, and similarly what we have is that distribution center for distribution center 2. Okay, sum of all 3 column wise, okay, equal to 1400 is something like column wise addition and row wise addition. That's it, nothing else. Okay, similarly for DC3. Okay, these 3 cells, products from A, B and C. Okay, now we finished the variables and the constraints. Now we will move it to the objective function. Objective function OF. Okay, what is our objective function? Is on cost. Okay, what we are going to do, it is to we are going to minimize. So our objective function is cost. Okay, we are going to minimize. Okay, before we move on, I want to explain to you a particular function called sum product. Okay, so you may be knowing the sum product function, but I just explain to you those who do not know the sum product function. Okay, so what I have is sum product function. We have two arrays. Okay, it can be a column array, it can be row array, or it can be a matrix like our cost matrix. Okay, so what I'm having 1 2 3 values in array 1. Similarly, if it is 3 values, array 2 must also have 3 values, 3 4 and 5. Okay, so what I'm going to do is, if I use the sum product, what it will do, it will just in this function, if I pass the array 1 and array 2, it will take the first value of the array 1 and the first value of array 2. It will do the product. First value of array 1, exactly the corresponding element. Okay, first value of array 2. Okay, it will do the product. Again, it will take the second value of array 1 and second value of array 2. It will do the product. Similarly, for the third value of array 1 and the third value of array 2, it will do the product. Okay, so for each corresponding elements, it will do the product, and finally it will do the sum of all these products. Sum of all this product. Okay, enter. So this is 26 here. Okay, what we'll do, we will do the sum product function. You see how to do that. Sum product. Okay, I send just the array 1 comma, this is my first array 1, array 2, enter. It will produce the same answer, because from the array 1 the correct exactly the same position value in the array 2, it will multiply each and finally give the sum. Okay, now we will move it to our problem. We have here the plant A DC1's unit cost. We are going to find out the number of products what we are going to produce. So each for example, we are producing 100 products and the unit cost for every product is 80, then overall cost is 800 for only for plant A to DC1. Okay, similarly for each cell we are going to put the number of products, so each cell corresponding unit cost is multiplied, then we will get to for each plant to each distribution center what is the cost involved. Okay, total cost involved, then we will add everything together, we get the overall cost. Okay, that is the cost we need to minimize. Okay, so for this what we need to do is, we need to first unit cost of plant A to DC1 into products what we are going to manufacture from plant A to DC1. Okay, this is the cost of plant A to DC1, total cost of plant A to DC1 plus. Okay, now plant A is A to DC2. now the same thing, unit cost of plant A to DC2 into number of products what we are going to produce in plant A to DC2 plus. Similarly, we need to add for every single corresponding cells. Okay, then add if you multiply corresponding cells, it will give total cost for that cell. Okay, then we will add all the costs, will give overall cost of this manufacturing and distribution. Okay, so we are not, similarly up to the final cell we need to add. For that, what we are going to do, instead of doing this way, we are going to use the sum product function. Okay, so sum product of, what is our coefficient, cost coefficients, this is one array. Okay, sum product will do as long as the array size is same. Here it is 3 by 3, it's also 3 by 3. Okay, this is first array is all the costs incurred, and the number of products we are going to find. These cells, currently it is 0, so there some product will give 0. Okay, so enter. So all this product we are doing using the sum product function. If you still having some problem or the functionality of sum product function, you can watch my previous videos on sum product function. I have lot of videos in sum product. Okay, it's a wonderful function. Excel user must know the sum product function. Okay, now what we are going to do, this is our objective function. So we set it up, everything fine. Now we are going to find only the number of products to be manufactured in each plant, or number of products to be sent it to each plant, each distribution center. Okay, so now what I am going to do, I am going to solve this problem. We formulated the problem very fine in the Excel worksheet. Now I am going to send it to the solver to solve this problem. Okay, where can I find the solver? Go to data. In the data there will be a group called analyze here. Okay, it is currently not there. Okay, because it is from the add-in, so I am going to add the add-in. Okay, it is always a good practice to add and solve the problem, then remove the add-in. Okay, remove means not uninstalling the add-in, it is just to uncheck the add-in in the Excel sheet, because it always it takes some time to load unnecessarily the add-in. Okay, when you open the Excel sheet, so whenever you want to solve it, you add. Okay, go to a file. Okay, how to add the add-in, solver add-in, file, go to options. You see in the options add-ins, the add-ins you can see solver add-in is already there. Okay, go to Excel add-ins. Okay, go, you can see the solver add-in is here. Okay, check it. Okay, then you find, press OK. Okay, now you go to data and see whether it is there. See the analyze. Okay, analyze group having the solver. Okay, so now just click on solver, then you have reset. I just reset the values. Okay, what is my objective function? I have already put it here. Okay, so my objective function cell is this one. Okay, this one having the my cost coefficients into number of products matrix. Okay, and overall sum. Okay, so this is the objective. Then what I need to do in the objective, set objective is this cell. Okay, I am passing the solver parameters now. Okay, now what is the objective? To minimize, okay, this cost. So set objective is this cell, we already kept it, and to minimize. Okay, then what is my changing variable cell? So obviously number of products, which is here. Okay, now we have done with objective function and changing variables. Now I am going to do the adding the constraints. Add. Okay, I'm going to add one by one the constraints. Left hand side of the capacity constraints, left hand side of uh, left hand side of the constraint plant A's capacity equal to right hand side, which we already kept it properly in left hand side and right hand side, so it is very easy to add the constraints. So I added one constraint. Again, plant B also, the left hand side for the capacity calculation must be equal to right hand side of the overall capacity, okay, which is 1900. Add. Okay, similarly for plant C, the calculation is here, which is the sum of all the plant C's distribution to distribution center 1, 2 and 3, okay, and equal to constraints 1600. Okay, add. Now you see here each constraint I am trying to add left hand side, right hand side, left hand side, right hand side, but if it is hundreds of these rows, then we no need to add one by one. Excel have the function have the flexibility to give as a array. Okay, so what I do, I delete these constraints. Objective is this one. Okay, so now what I'm going to do, I'm adding by sending just the array of left hand sides equal to array of right hand sides. Okay, it will split into 3 constraints because we send the same size array. Okay, add. Similarly for the demand constraints, which are all here. Okay, demands. Okay, this one also have left hand side and right hand side, because each distribution center cannot DC1 cannot go more than its capacity. Okay, so what is the left hand sides? This, and equal to this must be equal to the capacity. The calculation must be equal to capacity. Okay, it's so simple because we are already formulated the problem. Okay, so now make unconstrained variables non-negative, because the variables are supposed to be non-negative, because we cannot send a -1 product to plant A to distribution center. Okay, so the product is, the number of products is either 0 or greater than 0. Okay, so all variables are non-negative. Okay, so then select a solving problem is this is obviously simplex LP, linear programming problem, simplex LP. Okay, so you have select the GRG non-linear engine for solver problems that are smooth and non-linear. Okay, select the LP simplex engine for linear solving problem, and select the evolutionary engine for solver problems that are non-smooth. We have three types. Okay, here solving method, but in this problem, for distribution problem, it is simplex LP. Okay, then we have another thing called options. In the options, you can also put what is the precision for constraints, and what are all the maximum time you can allow, and iterations, all this stuff. Okay, these options I always most of the time the default is fine for us, but you want to restrict for some iteration number, maximum time, and ignore integer constraints and all those stuff, you can also set it. Okay, for this problem solving, I use the default one. You want to change it, probably you refer to the help of solver and see the each one what does it mean, and you change it accordingly. For example, you want to keep it for a maximum time. I want the problem to run only for 30, maybe it is in seconds, so I want it for 300 seconds, or only for I have time only for 6000 seconds, or 3600 seconds, or whatever way you want it, according to your timing you can set it. Or I want to do up to 500 iterations. Okay, these things you can set it, but this problem I just leave it as it is. Okay, so and also we no need to set it for this kind of small problems. It will do it in within 5 minutes. Okay, and solving method, you can select the solving method simplex LP, and I am going to solve it. Keep the solver find a solution. All constraints and optimal conditions are satisfied. Okay, then you also have the reports. What report you want to have, you can just click on your reports. Okay, press OK. Now what I have here is that you have the reports. Probably later you can, when you solve, you can see the report. The reports will have what is the final value, and what are the constraints, and what is the variable cells it found it, what is the initial value, and what is the final value, and so on, for the answer report, sensitivity report, and limits report. Okay, so but I'm going to explain to you only the answers. Okay, the answer what we have here is that DC plant A has to send manufacture and send products, 1400 products to DC1. Okay, and plant A is not sending anything to DC2 and DC3. Okay, it send its full capacity to DC1. Okay, for the DC1, the remaining capacity, the demand is split into 700 products from plant B, and C will send 200 products. Similarly, for DC2, the only plant C will send 1400 products, and plant B will send for DC3 1200 products. Okay, so basically DC1 receives from all the three plants. Okay, so this way when we solve the problem, the cost is minimum, which is $414,200. Okay, so this way you can use solver to solve your problems. Okay, transportation problem. Only thing is you need to formulate the problem properly. Okay, so we can also do a small for max fun. What we can do, we maximize and see what is the risk of having the, if we don't solve it the problem, and we randomly we allocate from plant A to DC1, DC2 and DC3, then what will be the risk? So I maximizing the problem and see the same constraints. See, this is $745,000. Okay, so if you, it also satisfy the capacity constraints properly, but the thing is, if you allocate this way, if you randomly do this way, your cost may be, you have a risk of the maximum cost of $745,400. Okay, but our actual cost is minimize, that is 745,000, but actual cost is 414,000, which is about a 3 point press OK, 414,000, which is about 330,000 more, okay, for the risk. So the maximum cost will be incurred by this problem 340,000 more, okay. So this is a wonderful distribution problem, and hope I explained up to your expectation to solve this problem. And you can remove the add-in by go to options, add-ins, go here and uncheck the solver add-in, okay. Then the opening time will be lesser, and you do other process, it is faster, okay. So now if you like my problems, like my solutions and my videos, please subscribe to my channel. Already it is shown in the screen already, the Alan Sam button. You just subscribe to that, and also leave your comments and suggestions if you find something wrong or anything in the solving of this problem, or if I can give a better explanation. Please leave it there, and I value your comments, and God bless you.